the domain and range of inverse trigonometric functions and use trigonometric inverse function notation to evaluate functions. So first of all, a quick review of inverse functions from some of the previous units. If f is a function, then these following statements are equivalent. It's not necessarily true in all cases, but they are equivalent. The inverse of a function is a function. So the inverse of a function is a function. F is 1 to 1. So what does 1 to 1 mean? It means it passes the vertical line test. It also passes the horizontal line test. And then the graph of f of x passes the horizontal line test. And the inverse of f of x, if it exists, is written as f inverse of x. So let's talk in detail about each of those a little more. First of all, a function must pass the vertical line test in order to have an inverse. And this should actually be a mistake here, horizontal. So in order to be a function itself, it must pass the vertical line test. So as you can see, both of these two, I have y equals x squared here. It passes the vertical line test, so that means it is a function, which means it can be written as f of x is equal to x squared. And then the second one I have also passes the vertical line test, so it means it can be written in function notation as well, x cubed. Okay. Now, when you're determining whether or not each of these functions has an inverse, you look to see if it passes the horizontal line test. Okay. And as you can see, this first one, f of x equals x squared, does not pass the horizontal line test because a horizontal line intersects that function at two spots, two different locations, which means it doesn't pass. F of x equals x cubed, on the other hand, a horizontal line would only hit it, as you move that horizontal line up and down, it would only hit the function at one location. And so it does pass the horizontal line test. So x cubed would have an inverse function, whereas y equals x squared would not. Now, that being said, we could restrict the domain such that f of x equals x squared does have an inverse. So for instance, I could get rid of this part of the function and restrict my domain to 0 to positive infinity. And if I were to do that, then I could find an inverse for f of x equal to x squared. Or I could do the opposite of that and restrict it to negative infinity up to 0. So domain restrictions are an option, which means when we're looking at trigonometric functions, we notice that, of course, they do not pass the, and once again I said vertical, the horizontal line test. This should be horizontal. Okay, so looking here at f of x equals sine x, if you look at a horizontal line through here, of course it does not pass because it's going to hit the function in infinitely many spots. Cosine of x, again, does not pass the horizontal line test. And then we have tangent of x, and you can see here it does not pass the horizontal line test. And so if we're going to define inverse functions for these trigonometric functions, then what we're going to need to do is restrict our domain. So let's start with the sine of x. And when we're thinking about the sine of x, we're thinking about our y value. So I have a unit circle here, and we know that the maximum is going to be up here at positive 1, and the minimum is down here at negative 1. Let's use the first quadrant. And so if I use quadrant 1, that will take care of part of it. And let's go down and look and see. Let's just look for one wave here. We have 1, 2 intersections, okay? And so what we're going to need to do is restrict that domain such that we have only one intersection there, okay? So that means that I want this one to be gone, okay? So this first one is okay, and that happens in the first quadrant. So we can use the second quadrant here. I'm sorry, the fourth quadrant, and that would take on this piece of the graph here till it gets to our minimum at -1. Notice here we're at our maximum of +1. Okay, so that portion of the graph, which is just half of a period, we would be okay. We would just have one intersection. So what that means is we could restrict, if I were to restrict my domain here, I would get to my maximum of +1. I would get to my minimum of -1. I would take on all of those values, but my domain would be restricted in here from -π/2 to π/2. Okay, so here at -π/2 I get -1, and here at +π/2 I get +1. So if I look at this now, just this graph that I have in here, and I restrict my domain, then that's the piece that I want to look at when I define my inverse, f inverse of x, which is going to be and I should probably, okay. So let's look at the next graph. Here we have cosine of x. Cosine of x, again, this time what we're doing is we're looking at our x values, and so we want to make sure we take on our peak and our valley, okay, going from lowest value to highest value. We know here at pi I'm going to get -1, and here at 0 I'm going to get +1. And so again, using that first quadrant and then trying to get them to be adjacent, here I notice I can restrict my graph from 0 to pi. And so if I do that, so if I were not to restrict it, notice that you have all of these times here that when we're looking at the horizontal line test, you have all of these different points right here where your horizontal line is going to touch the graph of cosine x. And now let's see if we can change that by restricting the domain. And so we've restricted it from 0 up to pi. And again, that's a half a period, so that's just moving from here to here, a half period. But it is going to take on all of the possible values there within that half period. And what I would get is in here it is going to pass the horizontal line test, only touching at one point. So I'm going to get rid of this piece of the graph and all of this over here, and we're just working here between 0 and pi. So when we have cosine x, if we would like to work with the inverse, then we're going to need to restrict our domain, in this case, from 0 to pi. Okay, and then the last one, let's take a look at tangent. Tangent, it's easier to just look at the graph. Again, going through, doesn't pass the horizontal line test. We need restrictions. We know we have asymptotes at -π/2 and at pi/2. So we've got asymptotes about right here and about right here. If I were to restrict between these two asymptotes, then I notice that I'm down to one intersection. So that means it would pass the horizontal line test. So for tangent, if we want to find an inverse function, then we're going to need to restrict our domain from -π/2 to pi/2. Okay, so let's talk first about the specifics of the inverse sine function. First of all, if we're going to find the inverse function, then remember what that means is that our x and y are going to interchange. And so when we're talking about f of x is equal to the sine of x, we know that our domain is all real numbers and our range is going to go from -1 to +1. So in this case, we notice that our input, since we're dealing with the inverse here, then this here is going to become our domain, whereas it was our range for sine of x. So this unique number here, and we're going to have the interval from -π/2 to π/2. The notation for this is going to be here. So sine inverse of v is equal to u. And what that means is when we're looking for the inverse sine of v, that means that we are saying the sine of what is going to give us v. And we'll look at a couple examples that will help us with that. But let's also look at another property here. If the sine and the inverse sine, those two are going to undo each other. So the inverse sine of the sine of u would just be equal to u. And the sine of the inverse sine of v would be equal to v. And of course that's adhering to these values that we have. So let's apply these a couple of times. Let's say we're trying to find the so that means that we can change this. Let's go back and look at what we were saying earlier. So this piece here is what we're going to use to find the answer. How do we translate the inverse into something that we are familiar with? And what we're familiar with is this piece. Okay. So what I'm going to do is just set this equal to a. Then what this means is the sine of a is equal to √3/2. So the sine of what angle is equal to √3/2. And once we word it like that, then we can quickly say, well, we know that the angle has to be π/3. Okay, and now for the next one, the inverse sine of -1. So again, we can take this and rewrite the statement. Let's say this is b. So then I can translate it into the sine of what angle is equal to -1. And once I look at it like that, I realize that my angle must be -π/2. Okay, and again, you have to remember your restrictions. We were dealing with sine here. We were dealing with sine, and when we're dealing with sine, we have to remember that we're restricted to this domain. And that domain would be, of course, when you're dealing with the sine of x. All right, so now what we're going to do is explain why the inverse sine of the sine of π/4 is equal to π/4, yet at the same time, this statement is not true. Okay? So, inverse sine. Just like with any algebraic equation, you're going to start from the inside and then work your way through the problem. So the first thing I'm going to do is say, okay, the sine of π/4. And I know that the sine of π/4 is going to be √2/2. And I'm trying to figure out if it's equal to π/4. So now as I continue to simplify, I get the inverse sine of √2/2. And we know that means the sine of what angle is equal to √2/2. And for right now, it's going to be probably helpful if we were to write that out. Let's say A. So sine of A is equal to √2/2. And then once we see that, we realize that A has got to be equal to π/4. And now you notice that that matches. Okay. And now let's look at the next example. We're trying to figure out why it's not true. So we've got the sine of 7 pi over 4. Let me fix that. Okay, so first of all, you need to notice that we're dealing with this. And when we're dealing with that, you know you're going to have a domain restriction. And that domain restriction is negative pi over 2 to pi over 2. So again, we start from the inside and work through our problem. We know that the sine of 7 pi over 4 is negative root 2 over 2. There are no restrictions in this case. Okay. Now when we get to this part, because at this point we're dealing now with this is going to come into play, our domain restriction. And so with that, we've got sine, I'll set this equal to b, of b is equal to negative root 2 over 2. And so we must find a value for b that meets this condition. And so it must be that b is going to be equal to negative pi over 4. And at this point, you notice that negative pi over 4 is not equal to the 7 pi over 4. And so the reason for this is mainly because of the 7 pi over 4 is not in the interval from negative pi over 2 to pi over 2. Now let's take a look at the cosine function. So again, for the cosine function, the input values are going to become what the range values were for cosine of x. So for cosine of x, the range was from negative 1 to positive 1. That's now going to be the domain for the inverse cosine, also known as the arc cosine, and as well as the same thing for the sine. That could be the arc sine. The inverse is known as the arc sine. So again, we have the statement here that we're going to use, which you probably understand a little more this time, and then the properties of the inverse cosine are going to be here as well. Okay, so the inverse cosine of cosine of u is just equal to u. These two, you can sort of think of them as they undo each other because they are inverses. And let's apply a couple of those. So in the first one, we have cosine or arc cosine of 1, and let's set that equal to a. So then if I translate that statement, then that means that the cosine of some angle is equal to 1. At this point, you must remember your domain restrictions for this function. So since we've translated it to the cosine of a, we have to go back to our domain restrictions, and this time we know that our domain restrictions are going to be from 0 to pi. And so in this case, we know that we have to get a, the angle A is 0. And then for B, arc cosine of negative root 2 over 2. We're going to be dealing with restrictions because we've got the arc cosine. So let's set this equal to b. Again, I'm dealing with domain restrictions from 0 to pi, and that's because the original problem started as an inverse. And then I know that b would be equal to 3 pi over 4. And then for the last one is a calculator application. So on this last problem, The reason you know you're going to need to use your calculator with this one is because 0.14 is not one of the coordinates on your unit circle, and so we need to use our calculator. And for the calculator, you just need to use your second key and then use your cosine. Okay, and you'll notice right up above that cosine it'll have this. Okay, and so you do that, and it will give you the value for this, which is 1.43, and you notice that that value is actually in your interval that you have defined. Alright, and let's talk about, actually before we get to the tangent, let's talk about one misconception. One misconception is the difference between 1 over cosine x. We know 1 over cosine x is secant of x. Okay? This is not equal to, and that's the same with sine and tangent as well. So the arc, this is the arc cosine, the inverse. This does have domain restrictions, okay, but it's not equal to the secant. Okay. And now for tangent. Tangent, much like the others, we're going to have a statement here that's going to help us transform the inverse into something familiar. We have to remember that our domain restriction there, once we do transform it, and then we also have the properties that we want to keep in mind. And so a couple of examples. So we have the tangent, arctangent of -1. Let's go ahead and set that equal to a. So we can say that the tangent of a is equal to -1. In this case, we know we have to have our domain restrictions from -π/2 to π/2. And what angle values satisfy that? And we know that that is going to be a is equal to -π/4. Okay. And then for our second example, okay, we notice that we have -14. In this case, we're going to have to use our calculator. And that's because -14 is not one of the coordinates on our unit circle. And so again, we're going to use our second key and then use your tangent key. And at that point you enter your 14, and our output should be -1.4995, okay, which does fall within your domain restrictions. And that's all I have for section 8.2.